Hello and welcome to the Coder Career Podcast. My name is Cameron. I'm a former technical recruiter turned software engineer.
Hi everyone, my name's Colin and I'm a senior software engineer and former instructor at CodeClan.
Cool. So, how are we doing today, Colin, on this sort of fine and cold Monday evening?
Pretty good. I'm kind of liking the slight darkness on the nights we're getting a little bit. Like it means that I can turn my LEDs on here and you can actually see them. So you know I can fiddle with the buttons and we can make pretty colors later on if we get bored.
Yeah, to be fair, I've got RGB on my ring light as well. But the cold and the dark and the rain, that is the words of a man who is not playing grassroots rugby because I can still barely feel my fingers from Saturday. Like they're sore. I thought
Oh
they
my
were going to
goodness!
drop off.
As long as your head's okay, that's the main thing.
The head's okay. Yeah, I mean, a bit of behind the scenes with Coda Career. It's always on Sundays we're planning on recording, and there's always a bit of a caveat of as long as Cam doesn't get a knock to the head. So we're all good. Although you dropped a can of paint on yourself, didn't you recently? So
How
to be
did you?
fair,
Did I tell you about that? I
yeah, we
forgot
had to
that.
delay the podcast because of it.
Oh man, I was painting the porch, and I had just finished painting the porch, doing all the painting, and I set the can I set the can of paint on the ladders, and I like they have a table on them, and I've lifted the ladders, and then the paint got knocked and went right on. Oh god, what a nightmare!
I'd
Yeah,
say it
what
happens
a
to the
nightmare.
best of us, but I've avoided painting and decorating for my 27 years on God's green earth. So
Painting and decorating is
yeah.
awful.
Yeah,
It's
give me
awful.
CSS over
Yeah.
painting and decorating any day. And speaking of code, actually,
Yep.
to tee you up a little bit, I'm quite excited for this one.
Yep.
It's a what really is, and it's the difference between software engineering and coding. And a bit of a callback to your first appearance on this podcast. Do you want to intro a little bit about what you mean by that and how it's almost your trademark thing?
It kind of has become that, isn't it? I think I said something like the software engineering is coding is not software engineering, but uh, software engineering is coding. But basically, what we're going to talk about today is we're going to talk about the differences between the two. And I think the kind of reason that I said it and the reason why that was a really interesting discussion point is because as somebody who's like been teaching, junior engineers and mentoring junior engineers, and being an instructor in a boot camp and things, I learned that a lot of people sometimes think that once they learn how to code, like that's it. Like you've learned to code,
Mm,
check, I can now code. And in some cases that's true. Like there is a lot of truth behind that because like learning a code is kind of like learning how to ride a bike in some respects. Once you know how to do it, you'll you'll never forget. You'll get rusty if you don't keep up to date, and that's definitely a thing that happens. But once you've like overcame that kind of initial like aha moment in your head for the first few times when you're learning to code for the very first time, no one can ever really take that away from you. Um, but one thing that is really important to understand that is that you're going to spend like a year or 6 months of your life learning how to code, but then you're going to spend the rest of your life, the rest of your career, essentially trying to master that. And that's the really important point that I want to try and get people to understand is that coding is just one part of like software engineering as a whole.
yeah, that's certainly true, and it's one of those things that I've never been able to properly put it into words until you came on the pod
Hmm.
and explained that. Because there's definitely, there's coding like a means to an end, like a loop is a loop, a variable is a variable. These basic concepts remain the same in almost entirely across all major programming languages, but the craft, like I know some people call themselves a software craftsman. I personally wouldn't, but like the craft of being a software engineer is very different to actually physically writing some code. I mean, we have some show notes before we go on this, and like for example, you said, so a quote from those notes is a simple Python to crunch some numbers. Like it's all well and good writing a bit of that, and that is great, and that's awesome if you've learned how to do that. But how can we apply those principles to create modern scalable systems that we can use for some kind of enterprise application, something commercially useful?
Yeah, exactly. So that the point about a little bit of Python is really a good one because you can learn Python as a first language, and a lot of people do, but it's totally fine if you just want to learn enough Python to be able to crunch some numbers or pull some data out of CSV, like do some basic mathematics on those on that data, transform that data somehow, stick it in a different file, and oops, you don't have to have a tremendous amount of like really like extensible software engineering knowledge to be able to do that. But if you then wanted to then say, for example, take that little demo application that pulls and pushes some data around and in and out of CSVs and spreadsheets and text files or whatever it is that you're doing, and then you wanted to turn that into more of a fully fledged application that has a UI, maybe has a proper database, maybe has like a proper backend. There's actually like tons and tons and tons and tons of things that you have to do to take that little almost like that little idea or proof of concept or little script, if you like, really, and turn it into a fully fledged application. And and I think like in some respects, I'm going to kind of give you two definitions of like what a software engineer is versus a coder. And the first one is really is this one that we want to hit on. And the first takeaway point is this: it's that you said it's craft, about crafting and code craft, and that is the idea that you're making code that isn't just something that you can just like write and then run once and then you run it again and then you run it again and you just keep rerunning that little block of code. It's more about how do we make that piece of code so that it can be maintained easier? How do we make it so that it can be reused, but reused in a way that's going to be helpful? I mean, like, I'm just sort of thinking back to the amount of times that someone's said to me, "Oh, you wanna do X, Y, Z? Oh, all you got to do is you pull this repo, you check out this branch, you like find this file, you run that file, and then that gives you this other file, and then once you've got that other file, you then run this other file on that, and then you're essentially like doing a thing by running a bunch of random scripts that someone's put together that like aren't related or connected in any like suitable or like well thought out way, because what they've done is they've like built a bunch of scripts and just stuck them together, but they've not really thought about like how do I turn this into like a product that
Mm,
someone can use, or maybe not even a product but like a tool that someone can use in the organization. Could I put a web front end on this and make it so that like everyone else in the org can like use this little tool without having to like clone a repo, chmod a file, run the file, run the other file, and then like all that sort of thing. And that's about extensibility, and that applies to like little small projects, and it applies even more to big projects. And then the other one is testability, being able to make sure that something's testable. um Kind of speaks for itself, and we'll talk a little bit more about that in a little while. And then there's reliable, which means that it can run reliably, and that's a lot more to do with how it runs and where it runs and all the rest of it. Like, does it run on is it a mobile phone app? Is it like a little Python script that just runs on a server? Does it run on your machine? Does it run on someone else's machine? Does it run in the browser? Like, where is this thing actually running? And then the biggest one that people tend to get get in a lot of trouble with is extendability. And for little tools that you're running locally, you might not want to extend that into some bigger application. It might just be fine that you've got that Python script and it does that little thing as your tool. But for the most part, we're not always making tools. For the most part, we're making applications. We're making things that do stuff for our users. So all of these kind of traits, maintainable, reusable, testable, reliable, and extendable, they're all much more important when it comes to building code for our users, building code that's going to do something uh, and serve some sort of business value. And yeah, like I think those have been, you'll have heard of like the solid principles. Have you heard of
mhm.
those?
Yeah.
I talk about those a bit when I talk about this sort of stuff, but I tend to kind of avoid them because when I'm doing this like initial like what is software engineering, because solid principles are really technically for primarily for object oriented programming. They're not It's not for generic programming. You can apply a lot of the solid principles to both functional and non-functional code and object-oriented code, obviously. But I kind of tend to take a little bit more of a high level, like you want to make stuff that's maintainable, reusable, testable, reliable, and extendable, and all that. Basically, all the ubbles. Apply all the take all of the ubbles, and that's what you want your code to be like. Now, as I said before, you don't want to. You don't nearly. You don't need to make your little Python script that spits out nicely formatted JSON for your little tool that you're running locally. That doesn't need to be any of those things. But when it comes to taking something like that and then building it into a bigger project, you definitely want to do some of that stuff, and we'll
Mm.
give you a little bit of an insight how.
Your first point really interests me actually because it's kind of like the DIY don't repeat yourself philosophy. Um, Most people
Yeah.
think of that in context of a single file or script or whatever, but actually, don't repeat yourself could be extended to someone having to constantly over and over and over do a manual process externally, whether as you said, like um, go and clone repos, like mess about, run
Mhm.
different files, then move on to a new file and chmod something, and even for an engineer that's a headache. Whereas, and like you say, like the DIY process probably usually would end in a result like a front end application of some kind, and that's why. Well, I mean, that's why internal tools is such a big area. Like we don't talk that much about our day jobs on this, but my day job, I just work on internal tools all day in day
Ah,
out.
right.
I love it. I
Okay.
find it really interesting, and making everyone else in the organization's life easier is actually quite a nice thing to do.
Yeah, it definitely is. I mean, and it's interesting that you do that because, and this is like a really interesting little segue that we didn't intend on speaking about, but companies that prioritize building of internal tools, a lot of respect for that. That's a really good sign of a company that's willing to do engineering well, because ultimately you can't build good software for your customer if you're not able to take the time to build good experiences for your developers. That's kind of goes without saying that, even though it doesn't happen everywhere, that spend a bit of time building something that you're going to reuse again and again and again as an eternal tool, whether it be like some internal facing web app, or like an internal facing like bunch of scripts or command line. We've got tons of command line tools in the place of work, and I think there's so many that there've people have like reinvented the wheel several times because it's quite a big org, but that's okay though. And there's some really pretty nifty command line tools you can get for like lots of cool things. Like we've got all of our stuff for example, connecting to Kubernetes and checking the status of the clusters on dev, and checking what the pods are doing and looking at logs. And there's like web app tools for building entire services. It's really really pretty cool. So the amount of things you can turn from little simple experimental products into
Mm.
full blown applications, just using some just applying the same software engineering smarts that you would to your developers, as you would your customers to your developers, and it can go a long way.
I remember you
Yeah, it's
saying at
really cool.
CoClan you used to have a command line script to literally set up a machine, which I always thought was pretty cool. And I think that is
Yeah,
actually available on GitHub. So if you
it
want to check
is.
it
It's
out,
actually open source. Yeah, yeah,
yeah. In fact, actually, it's a bit earlier than usual, but we're splicing the CoClan advertisement now, and
absolutely.
people can find out a bit more about them. The Coder Career Podcast is brought to you by CodeClan. As the only coding bootcamp in Scotland, CodeClan is a fantastic way for people in Edinburgh and Glasgow to learn to code in person. And if you're elsewhere in the UK, you can still benefit from their remote cohorts. With over 1,500 graduates, 70% of which get a full-time job within 6 months at one of CodeClan's 390 hiring partners, CodeClan is a fantastic place to make a change in your career. CodeClan is also making great strides towards reducing the gender gap in technology, with over 25% of their alumni now being female, with this rapidly growing. With average starting salaries of around £30,000, a world-class curriculum, and a forward-thinking organisation, CodeClan is the place to be. As a former senior instructor at CodeClan, Colin can tell us even more.
Yeah, absolutely. CodeClan is an absolutely phenomenal place to be, place to work, place to study. It's a coding bootcamp, and it does full time professional software engineering and data courses. The software engineering course is called the PSD, and the data course is called the PDA. Both these courses are 12 to 16 weeks full time. They are fully instructor led, which is 100% instructor interaction. That's one of the things that really sets them apart from other courses that you can take. For example, you can do quite a lot of courses online for coding and software engineering that are not instructor led and are maybe through like a learning platform. Whereas CodeClan stuff, whether it's remote or in person, they're fully instructor led. You can literally stop the instructor halfway through a lesson to ask a question, and if anything, that's actually encouraged. The whole course is designed to take someone who has very little experience all the way up to a junior software engineer, such that they're able to become a junior software engineer in an organization. And the course hits on all of the basics, mostly around Python, JavaScript, Java, but as well as that, the software engineering principles and all of the really important fundamentals behind software engineering and coding and clean code. That all gets taught in this interactive, immersive way at CodeClan. One of the other great things about CodeClan is that people often say, can I learn like Rust or can I learn Swift or something like that? You actually can't like learn tons and tons and tons of things on the course because there only is so much time and you can only fit in so many like languages and skills. But one of the great things about it is that it gives you the ability to learn those things later on. It doesn't just say here's React and here's JavaScript and whatever else, and then off you go. The instructors that you get on CodeClan are so helpful, and they're so good at knowing exactly what people are thinking and feeling at various points in the course because it is a very intensive course. But at least there's between 2 to 4 instructors per class, and that's for both remote classes and in-person classes. And everyone learns in the cohort at the same pace, which is excellent. It's really good to know that, for example, the way that they teach on the course, which is so important to me, the way that they teach is that they use a lot of what we called code alongs. And a code along is where an instructor kind of quite slowly and methodically codes out something in front of the class, whether it's on Zoom or in person in the classroom. And then the class slowly like code that thing together. We call that a code along. And that's actually a really powerful way to learn because you're seeing the actual coding process happen in front of you, but you're also being taught at the same time. And as a participant, as a student, what you can actually do is you can stop and you can have a conversation and you can ask questions. CodeClan is kind of a life changing thing. I've seen dozens and dozens and hundreds of people go through it in the time that I was there, and it was genuinely life changing for every single one of them. They managed to get jobs as software engineers, junior software engineers in the industry, and even now, uh, being a couple of years ago that I worked there, I know many of the people I know are now mid level, kind of senior level engineers. So it's having a huge impact on people's lives and in a way that I couldn't even describe. It's pretty awesome. To get more information about CodeClan, go to codeclan.com and slash events, codeclan.com slash events to learn more and to register for a workshop. The workshops that they do are kind of like a way of you figuring out if you want to come along to CodeClan and join up and do the course. And it's a really great way of figuring out if this is the sort of thing that's going to be useful to you. Please give it a try if you're thinking about it. I highly recommend it. It's absolutely fantastic, genuinely life changing. Okay, yeah, so CodeClan is awesome. Please check out their website. And just before that little split, we were talking about the laptop script that they've got, which is a really good, really great laptop script. If you get a brand new MacBook Pro or any kind of Mac actually, and you want to get into engineering, I think it's github.com/codeclan/laptop from what I remember. If I've got that right, I should get some sort of prize. github.com
Links in the
slash
description regardless, so you
yeah, yeah,
can
yeah,
join
yeah.
our
The correct
Discord.
like the correct link is in the description. github.com/codeclan/laptop, and they've got a really cool laptop script. You run that bad boy, and it turns your machine into a fully fledged dev machine. I'm pretty sure it still works. I don't know if they use it as much as they used to, but we definitely used it a lot when I was there, and it's really great. It gives you all the tools you need to dev stuff. Okay, so like back onto the kind of main topic in hand here. We're talking about what is software engineering and how does it differ from coding. That's kind of where we're going with this episode. And what I want to really get over is as we write as we write um, small reusable parts of our code, which is something we should be trying to do, they'll build up to become bigger features, and these small reusable parts might have quite a lot of logic in them. And as a result, like for example, you might have some method that you might have some method that does quite a lot of stuff, but you want to be able to make sure that thing's working exactly how you want. So this is where this concept of testability comes in. You want to make sure it's tested. So if you want to make sure something's testable, that means that you have to kind of almost break it down so that you can check the result of that that chunk and have a value returned from it. One thing just quickly is a lot of mistake that a lot of people make, particularly when they're building command line tools, is they'll do, and I'll talk about this in a bit more in a minute, but they'll do a lot of the printing out to the command line, like inside the logic of the thing that they're building. And what that means is if you've got some method that does something like compares like let's say it's a card game example where um you've got two cards, you want to compare it, compare these two cards and tell you if they're the same card or find out the difference between them. Then what a lot of people do is they get that method to print out that value rather than returning it, which and then having it printed out. And that's just such a big learning piece when you're figuring out how to go from just being a coder to being like a software engineer and use some software engineering principles. And as I mentioned before, the solid principles of are for primarily for object oriented design. That's if you're using things like Java, JavaScript, like Python, and those languages, then solid principles can apply a lot to them. Um, and one of the biggest, most important ones that I want to highlight out of that is the S, which stands for single responsibility. So single responsibility is is my favorite of the solid principles, and it basically says that one thing, one class, one method, one function should just do what that one thing. It shouldn't do any more than that. Um, an example of that is something like what I said a minute ago, having something do perform a calculation or um, taking some value, changing it around, and then rather than what a lot of beginners that don't understand that rule, that single responsibility rule, do is they have that thing printed out. So in the function, they go do my calculation, print it, and then the function returns nothing. What you want to do is you want to have take the values in, do the crunching on that value, do whatever needs to be done, and return it. And then the thing that calls it can then do the printing, or it can be
Yeah.
passed back up the chain and have it done like that. And what we're really talking about there is what's called the difference between tight and loose coupling. And tight coupling is is when we've got something that it tries to do everything at once, right? And anyone that's ever written any piece of code that's beyond a basic kind of a beyond the basic like hello world or a little bit more complicated than that, you'll find as you start to learn how to code, you find that what happens is your code you end up putting everything into one function or everything that goes into one method, and then you run it and you're like, this is great, it works, and then you realize that it's really confusing, or you've done it but you go to read the code and you don't quite understand it and you're kind of cocking your head to one side to try and read it, and you're thinking it made sense at the time, doesn't make sense now. And the reason for that is because you need to try and abide by the single responsibility rule, which is if I've got a method that like adds these two values, it just adds these two values. It doesn't add these two values and then send the value to another server. It just adds those two values. And then you return that, and then you have another method that says send it to the server, do whatever it is you want to do. Um,
You know,
I've,
someone
have you?
actually commented on TikTok about solid principles the other day. I don't know
Oh
if you
yeah,
saw that. It was one of the ones where it was like the concepts explained using Earl series,
yeah.
and it was one where what was I explaining?
Was it the
Um,
dry? You were talking about dry on TikTok with Errol once.
Yes, yeah, yeah, I was talking about dry, and then someone commented on it saying, so you can use dry to like have a function to feed it about whether it's like wet food or dry food or dinner or lunch or whatever,
Hmm.
but because of solid principles, he obviously didn't know my name, so he was like, you can't use that function to feed Earl's owner. Which is a very good point because it's a different process, and
Haha.
you're not abiding by the single by the single rule there, which I thought was cool. And actually, I
That
might
is
actually
cool.
steal that for a TikTok. So if you are listening, I will tag you in that TikTok.
That is cool. But then I could argue this is where the solid principles get quite wacky, right? And don't get me quote all of them because that would put me embarrassingly on the spot. I think I know most of them. One of the more interesting ones is the Liskov substitution principle, and this is perfect for what you just said, right? The Liskov substitution principle says that if you've got two objects that are different, then you need to figure out if you want to allow those objects to be replaceable, right? So let's say you've got a method, okay, and it takes an object as its argument. You pass that object into the method, and then let's say the method is, in this case, for your example, the method is feed, but the object is Earl. You pass in Earl, right? And then let's say the method is still feed, and it doesn't take a Cameron.
Yeah,
Okay, it doesn't take an object of type Cameron. But what you can do, and you can do this much easier in things like Java, C Sharp, C++, like and a bunch of other statically typed languages, is you can make the Cameron object and the Earl object. You can make them like we call it polymorphic. It's a big word that means that they are the same, that they share a type. Basically,
it's
it
like a
means that
type union in TypeScript, or is that different?
it's a bit different from that. It's kind of similar. Yeah, you can treat type unions the same,
Hmm.
but this is more to do with like you either use inheritance or they have them share an interface. And what you could do is you could say, right, well, I want to make my Cameron object feedable, and I want to make my Earl object feedable, and then I rewrite the feed method to not accept Cameron, but and not accept Errol, but instead accept an object of type feedable. And because Cameron and Errol are both feedable, that's me abiding by the Liskov substitution principle, which means that I can take two objects that are the same, that are different types but the same base type, and then pass them in.
But you
And this is
introduce a
why it's
potential
like,
bug here, though, because either Earl gets a takeaway pizza and I get cat food. Like
well,
you have
that's
to be
where
very, it
that's
has to be well
yeah,
tested, right?
that's where you need to kind of be a bit careful about it. Yeah, yeah, yeah. Object oriented programming is a bit wacky like that, and but it's something that definitely applies a lot more to like C sharp and Java and all the rest of it. And
You
it's
know,
single
it's a side note.
responsibility.
I was actually saying that on TikTok the other day, um, where C sharp is like one of the most underrated languages for people to learn. Like,
It's
for
very cool.
actually how many jobs there are on the market, it's quite a well liked language. You can get into stuff like gaming via Unity. There's actually a lot you can do with it, and because it's relatively syntax wise similar to Java, it's fairly easy
Mm.
to learn what to learn each of them. So it's an underrated one. It's funny because people tend not to talk about it, and actually, it's it's a good one to learn. Like I would say, in most of my exposure in the tech industry, C sharp seems to be hiding in everyone's tech stack somewhere.
I've used it once for a project years ago, and back then it was awful, but it was more or less awful because of the tooling at that point in time. Now,
Hmm.
here's one of the really cool things about Microsoft. Going to big up Microsoft for a minute. In the years since the Microsoft olden days, their approach to like open source, their approach to um, tooling for for platforms other than Windows has been absolutely tremendous. So for a good few years now, you've been able to brew install .NET, basically install .NET on any .NET. It's called .NET Core, I think. Install .NET on any machine, Linux, Mac, like obviously Windows, because it's primarily built for that.
Yeah,
But
you'd hope so.
you know, back in the day, you could only get it for Windows, and that was kind of made me a bit kind of put me off it. But now you can quite easily and really nicely install .NET for any platform. They open sourced the .NET like core stuff years ago, and they support a really good community behind it. I think they also support, like Microsoft also do a lot of really good support for TypeScript community, and obviously they bought GitHub, and VS Code is a big deal too. So yeah, there's some pretty like, I mean, it used to be when I got into IT 2008, like Microsoft was such a bad word, and over the years they've done some really really cool stuff, and this has been a really interesting little segue
Yeah.
into how awesome Microsoft is. We
Everyone
love
tag
you,
Microsoft
Microsoft.
on YouTube.
Yeah.
If only you could comment on Spotify, get on our TikTok and tag Microsoft because we want to get paid. We want to get some of that Microsoft money.
It's not just that. I just think like Microsoft's cool. Like, and I can't believe I'm saying that because like me 20 years ago would just be like, oh, it's the devil, But
Well,
it's
it's good
awesome.
to change your
Microsoft's awesome.
opinions, right? Like
Yeah, definitely.
what was it you said a while ago? Strong opinions loosely held.
Yeah, I probably did say that. It's a it's a classic senior software engineer thing, right? Like you've got that's one of the tenets to becoming a senior software engineer. It's very difficult to do. Yeah, yeah. So back to the tech stuff. That kind of rant there earlier on was basically just um, about how we should try and make things what we call loosely coupled. And what does that mean? Okay, so have you ever written a card game,
I
a
have.
command line based card game? You
Yeah, it
have.
wasn't a
Yeah.
well, it was a card game, but it was a probability calculator and poker
Okay.
simulator to try and make me a Vegas billionaire. And
Okay. Cool. Right.
yeah, as
And
you
did
can
you
see,
have it like
it was running on
you're
the
not a
card line.
you're
Well,
not
I
a
was gonna,
Vegas billionaire? I thought that you were.
I am
I
still
thought you
in,
just done this for kicks.
I'm still in a flat in Edinburgh right now, so I
Huh.
think you know how that ended. Um,
Edinburgh's an expensive city, mate.
yeah, that's true. Yeah, that is true. To be fair, but yeah, it did not make me millions, but it was a useful learning experience. Basically, yeah, I more or less refreshed myself on Python using it, and it was a yeah. In short, I have built one. Yes, sorry, what were you going to say?
Nah, it's cool. It's good to know. So when you built it, did you make it so that when like the bits of the code that done the calculations, the logicy bits and all the rest of it, did that do the printing out? Or did you have the printing out separate from the calculation part, if that makes
S-
any sense?
So I went through that process that you discussed actually earlier, where it was a mishmash mess, and I think it literally was one giant method.
Yeah.
It was horrible, and then yeah, I did. I kind of I want to say it was very deliberate how I built the scaffolding by doing it in one like big method and then split it out. But
Mhm.
in reality, I just panicked when I looked at it and thought this is useless. And like, God knows if I look back on this a day later and don't understand it, if God forbid I walk outside and I do get hit by the 16 bus. And you have to look at it to try and
Yeah.
do what I could not do and win those billions in Vegas, are you going to understand my spaghetti code? No, because it wasn't separated enough, and
Yeah.
and stuff wasn't abiding by the solid principles. So yeah, eventually it did migrate towards that, and I think that comes with experience a little bit, but it's always something worth
Definitely
keeping in mind.
does. It definitely does. Like it's really hard to go from I have just learned to code and feel that you're pretty confident with it and able to do some really cool stuff, and then it runs and it works and you go, well, hey, it's difficult to go from that to I have written this piece of code which is extendable, reusable, testable.
Mm,
It conforms to all the solid principles. Like that takes. Then that's a really big takeaway from this episode, by the way, folks. That takes the rest of your career to do that. Like there's days where I write some stuff and I look at it and go, oh no, that's not quite right, and I have to refactor it a few times before it's exactly how you want it to be in terms of that stuff, and then it'll go to PR review, and somebody will go, actually, you should split that into two methods because that's one you've just written something this big, and it needs
yeah,
to be you really want two things that big rather than one thing this big, and because it's ideally easier to read. But the point I'm going to make about the card game one is one of my favorite points that I learned teaching at Code Clan. We used to do card game stuff, get the students to write card games, and big mistake they always make is they go straight in and they write a bunch of logic, and then they have like the console.logs, or if you're in JS and system.outs, if you're in Java, it was mostly Java, um, inside the logic. Whereas what you really want, and that's called tightly coupling. And that's just one example of what tightly coupling is. But what tightly coupled means is that if you've got two, if you've got two like pieces of logic, or two functions, two methods, two classes, two somethings. It could even be two parts of your program that are spread across multiple classes or modules or files. And if they interact in some way, and you can't run one without the other, that means that it's tightly coupled. In this case, for example, we couldn't run. Most students code it in such a way that you can't run the logic and not see all the printout stuff. Now the question then becomes: is what do you how what if you turn around after you've built that and say, I want you to make this game, this like card game that's like, let's say it's a poker card game, that right now you're controlling on the command line with little commands, and like a little, like shuffle command or whatever, and deal card command or whatever, and then you go from that to make this controllable via a REST API. At that point, like that really sends the students like, oh my god, what? How the hell am I going to do that? And then the challenge is I don't want to see any output from the console.logs, so they've got to go and rip all the console.logs out, and they've got to figure out a way to call that logic, but still get back the data in such a way that they know what the prints should be. And it's like, it's a really interesting one about loose versus tight coupling. And this is the difference between coding and software engineering, right? This is just one of the differences. And there's so many on this kind of level stuff that we could talk about: the solid principles, the loose versus tight coupling. If you build any sort of like any sort of system, and you've got the let's say you've got the bit that sends the data to the user, like the front end code, the UI code. If you've got the database code or the data, and if you've got the logic that drives it, if you've got that all intermingled and intertwined, it's going to be really hard to take that code and then extend it. And you might be able to extend it, and but it's what's probably going to happen is somebody else in your team is going to come along, look at the spaghetti, try and figure out how you've done it, and then just essentially copy and paste what the last person done. And then what's happening is you're compounding upon bad mistakes. So that bad mistake, that bad design decision, just gets propagated more and more and more into the code base. And that's why it's really important to care, because you're building this for your customer, you're building this for your end user, stakeholder. Over time, those software engineering practices are going to cause bugs, and they'll inevitably cause problems in the system, and new features just become harder and harder to write. And here's what happens: is that kludge becomes an undesirable to look at piece of code that nobody in your team is going to want to look at, and eventually your engineers will start to resent that code. So it's just so important that when you write code, that you're writing it in a clean way, you're writing it you're writing it in a way that you're making sure that you think at least it can be extended and reused and modified. But that discipline will take a long time to master. It'll be take a long time to become an expert on that. If ever, right? Like because it takes a long time to be able to get to that level.
Yeah, so people shouldn't worry if they're feeling like, oh, I'm
Yeah.
not ticking every single box here. Like a lot of, straight up, like
Yeah.
I'm not saying like the entire, we're 35 odd minutes in. I'm not saying, oh, I didn't know that. Like I'm already learning a lot from this. Like I'm not going to keep interrupting you, while you're explaining something, but I'm already learning a lot, and I'm someone who's been in the industry a little while. So if you're just learning at the moment, like don't panic about this, but it's something worth
Good
keeping in
point.
mind, as
Yeah.
you grow, because you're going to become an effective, and then so you become a senior developer far before most people, if you learn these principles early on and try and apply them to
Uh-huh.
what you're working on. And don't worry if you don't get them perfectly the first time. Like it's great if you're even trying to do things like simplify and split up your code, if
Mhm.
you're still in the learning process. Like just keep it in mind, but don't like freak out over it.
Definitely, and I've seen that happen. I've seen me like spend a week or 2 weeks teaching people the solid principles, then they go off and go do their projects. This is when I was an instructor, and they'd like try and burst out every single solid principle, and they'd be like, they come to me like crying and tearing their hair out, going, I don't understand. I can't get all. I need all of the solid principles. I was like, dude, you don't need all of the solid principles. Just like because it's about a balance, right? I keep hitting this
Mm,
thing. Sorry about that. It's a balance, right? Like if you like I don't make interfaces for every single in my code at work, right? I don't make interfaces for every single class because not everyone's going to use those classes. So why make interfaces for them? So the interface segregation principles just gets thrown out the window, like in most days. So you know, just take everything with a pinch of salt. Try and do your best. Try and get people to one really good way to tip to like learning this stuff is really just to get people's feedback. Find somebody, an engineer in your organization that you think is going to be somebody who's effective at giving you this kind of feedback and say, look, could I have written this any better? And that's just one quick point about code reviews. If you're a junior software engineer and you're putting up PRs and people are going LGTM looks good to me. Yep, brilliant, 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 brilliant for every single PR. That's can be a little bit worrying. I would try and get a little bit more
mm,
feedback on that because 9 times out of 10 there is something you could probably do to improve, and it might be that the person who read it either just didn't read it or read it and thought, actually, I'm not going to bother him with this because it's really just nitpicking. But sometimes, if you want to try and improve things like your the loose coupling and tight coupling in your code and your reusability and your clean code and your testability and your solid principles and all that sort of stuff, you're better to ask somebody and be like, look, what would be the is there an even better way I could do this, and just try and keep asking.
yeah, totally
um
agree with that. That's great advice.
yeah. Then the second part we're going to quickly talk about. Don't have much time to talk about this one, but definitely worth mentioning, and that is kind of a bit more of like my opinion of a modern software engineer, and it's kind of true, but becoming a software engineer like today, it's very important to understand this, I think, because it's not just about coding, and this is why coding is not software engineering, but software engineering. Have I got that right? What way around is it? Coding is not
I don't know if we
software
decided on the way
engineering.
around. Yeah, coding is not
Yeah,
software
but
engineering. Software engineering is the same thing.
software engineering
Yeah, you have to
is
code to do software
yeah,
engineering.
to do software engineering.
Yeah,
Um, but you can't do software engineering without coding. But coding on its own isn't software engineering, and that's the big point, right? And the reason for that is because today, we've got you got engineers that specialize in front end, you get engineers that specialize in back end. You get more and more companies these days that don't really care whether you're front end or back end. They just want an engineer. They just want a software
mm,
engineer. They want a developer. There's the same thing. And some places call that, oh, I want a full stack, or I am a full stack engineer. And um, actually, many of those activities across both front end and back end, tons and tons and tons of them are for software engineers are not like, how do I get better at writing code? They're not code problems. It's not algorithm exercises. It's not even solid principles. It's not object oriented design. It's things like, how do I build a really suitable like continuous integration and continuous deployment system? How do I use the Git or whatever effectively? How do I use that in such a way that stuff can be deployed? Configuration management, which is a whole other thing in software engineering, where you like are talking about configuring the services and servers the correct way, making sure that the dev code, the dev branch connects to the dev site, which connects to the dev server. It's all configured correctly. And then you've got a thing called observability, which is huge in modern software engineering. It's all about, how do we monitor our systems in the wild? How do we make sure that, like, we know that we're running like this service across 35 different machines? Has one of those machines went down? Is Has there been an error in that application somewhere? Like, what if the payment system, like, or the email system wasn't able to handle some requests for a while? How do you know? So observability is a principle around making sure that your stuff runs,
Yeah.
but you know about it. And there's tons
That's
of
so
really cool
important in stuff
tools.
like payments.
Yeah,
Like, um, she's not a software engineer,
everything.
but I was talking to my girlfriend about this a while ago, and one of her favorite like like either fashion or like cosmetics e-commerce sites like had a massive glitch
Uh-oh.
where basically everyone was getting 90% off. Like, so
Uh-oh.
everyone
Nice.
got 90% off no matter what you put in your basket, and people were saving hundreds and hundreds. Sorry if there's
Lovely.
a food process going on in the background.
Can't hear
um,
it.
so so people are saving hundreds of pounds basically by putting in these codes because they obviously hadn't observed it, and it went on for like over a day, which is really bad. And I imagine
That is bad.
they honoured it, but the company lost millions. So fair play whoever that was, but yeah, not great. It shows the importance of having something like Datadog.
Yeah, Datadog.
Get the dog tracking, and
Mhm.
they'll find those errors. Like, for example, today I deliberately broke something and didn't realize that it would log all over in Datadog and there would be Slack alerts and stuff. But here we are.
Oh, no.
It's all right. I explained what I did. That's the other thing as well. If you mess something up, just own up to it and explain what
Yeah,
happened. That's an important lesson that we don't have on here, but it's something we would always emphasize, I think.
definitely. And just for context there, Datadog is a tool that helps you with observability. It helps you see what's going on in your application out in the wild. It's a really, really useful tool. Another thing Datadog helps you do is it helps you track metrics. So let's say that you want to know every time someone puts a product in their basket, or you want to know how many times a cache gets missed, which means that the value is not read from the cache and it's read from the slow thing, or whatever. You can set up metrics and you can have them send out to something like Datadog, and like you can have them increment a counter, to see, oh, this cache has been missed like 100 times in the last day. That kind of comes into this observability piece. Um, Another one, the other big job that the modern software engineer has to do is system design. What is system design? Well, there's a whole episode we could do on that, but basically, you know, will calls from our mobile app crash the backend? Are there enough services there to like keep that running? Like, do we need a load balancer in there? Do we need a different kind of database in there? Like, should we have a database one per one service or shared between multiple? Secret answer. The answer is never shared database between multiple services. How do we take pressure off the system? How do we design it in such a way that it's not going to fall over? And if it does, there's resiliency and you there is when you become a kind of lead or senior software engineer, one of the interview uh, questions that you might get at that level is design me Twitter, design me Instagram. And what that means is you basically have to like know enough about how the big pieces building blocks of of infrastructure fit together to be able to design something like that. And that's a lot. That often happens to even some places that ask front end engineers, how would you design X? Because there's an expectation for how systems that should be built to be known by everyone. Um, how would you design Instagram? And they're not saying I want you to go and design Instagram right now. That's not what they're saying. You don't go in an interview and no one expects you to like sit there and start coding and like building Instagram. That's absolutely nuts. But what they do sometimes expect at these kind of level interviews is they want you to be able to go, okay, well, Instagram, let's say it gets like a 100,000 hits a day, and it's got like a million images. Those all have to get uploaded somewhere. It has to be fast, so it should be like a cache, or it doesn't have to be that fast, or whatever it is you decide. You've kind of got to make these little design decisions.
Mm.
You've got to like, do I want a Redis cache here? Do I want a database here? What kind of database do I want here? And you kind of got to know the difference between like your SQL database, your NoSQL database. Like, you've got to know about, then you can I just chuck a database cluster in there? And tons and tons and tons of really, really, really cool and interesting things like that. So big takeaway from that kind of that piece. So the old fashioned and still very current kind of concept of a software engineer of software engineering is it's not just coding because you essentially you're essentially an architect of code, but you also have to be an architect of systems and processes and practices and best practice across observability, system design, system architecture, CI/CD, and in some organizations, some of those responsibilities are like chopped up and passed around to different people. You know, for example, you'll have heard of DevOps. In some organizations, they have DevOps like dedicated people who handle all the like running of the services, they handle the deployment of the services, they handle the continuous delivery and continuous integration of those services. But my advice is to try and understand as much about all of that as possible. Try and give yourself the best chance of becoming like an absolutely brilliant like software engineer. And the very, very final point I'll make is, and I call myself this is I just call myself a software engineer. I don't call myself a full stack software engineer. I don't call myself a front end software engineer. Like I am supposed technically full stack because I believe that if someone says they're a software engineer, they should be able to do almost anything that someone asks them to. But it takes kind of like a little bit more kind of like experience to help people get to that level where they can deal with any problem that gets thrown at them. But that's kind of where I think that's where you should want to be as a software engineer rather than yeah, I know bits about this and bits about that, and that's great, but I'm not willing to learn or not willing to come out of my comfort zone and kind of learn that. So yeah, there's definitely good advice in some of that, I think.
Yeah, absolutely. I mean, I've just literally just been mentally thinking now, man, I think I can make about 50 TikTok clips of this. So thank you for making my job easier on that side of things. But yeah, I mean,
I think some
this
of
is
that was
one of
pure
the
drivel. I'm not gonna lie.
well, it sounded good from my side, mate. And I think this is one of those ones where, don't be afraid to go back and maybe listen to this, especially if you're learning now. Don't be afraid to go back and listen to this again in a few months' time, because I do think a lot of this is, it's, well, this is evergreen, right? So, always come back, because I feel like there's different levels to the advice here that you can learn from. And yeah, I thought that was awesome, Colin. Thanks so much for preparing all of this. That's
Well, there's
really
plenty
cool.
more opinions where that came from. We can just keep talking. Just record
Cool,
another
man.
episode after this.
Sounds good. And sorry to ask you this off the cuff on air, but if maybe we could do
Absolutely.
some kind of blog post on this as well, I think
Yeah, that'd be
that
great.
would be awesome.
Yeah.
But yeah, I want to thank the audience for tuning in, and please do join our Discord as well if you want to chat with me and Colin. It's one of those Discord servers. A lot of people plug their Discord, and there's like 20,000 people on there. You're never going to chat to the people that run the show. We're still a small show, and we really listen to all the support that and advice and feedback that we get. So, just jump on
Hmm.
there, have a chat with us. We're both nice guys, and the members on Discord are really a friendly bunch as well. And people have learned a lot and been really celebrating people's wins recently with getting
Our
jobs,
members
like
are
their first,
great.
second job. Yeah, they're
Like,
they're
shout
awesome.
out to our members, particularly shout out to Louise that helps everyone with their CV. Thanks, Louise. We love you. There's so many good people on there. We want people to like come on and give us some chat and get a bit of help. And yeah, we're dead keen for people to join. So it's decodercareer.com/discord, and just stick in your name and address, your name and email, and we'll you can join the Discord, no problem. And yeah, we're really keen to grow that and get lots and lots of people in there, build a little community around it.
Absolutely. And thank you for listening as well. If you haven't come across us before, as we just said, follow us on Discord, check out the other social channels we mentioned, and we will see you every other Monday. See you soon. Cheers.
Cheers.